We're now going to talk about the process of dividing polynomials. And we're going to do that using a method called synthetic division. Synthetic division essentially means that you are doing the division process with only the numbers, and you are leaving the variables out of the process. So our first example says that we want to use synthetic division to divide f of x is equal to 3x to the fourth plus 8x squared minus 7x plus 4 by a g function, which is x minus 1. So what I'm going to do is I'm going to begin by placing my f of x function underneath the division line. Now remember that we're only going to use the coefficients. So instead of writing 3x to the fourth, I'm just going to write the 3. Now, note that in our problem, in our function f, we are missing an x to the third term. So I'm going to put a 0 in there to hold that place. I have an 8x squared, so I'll use the 8. I have a negative 7, and I have a positive 4. Now, I'm dividing by x minus 1. So on the outside, I'm going to put the opposite of this number that I have here. So in that case, I'm going to put a positive 1 on the outside. Now, synthetic division is simply a repetition of multiplication and addition. So what we're going to do to begin is we're going to take this first number and we're going to drop it down. I'm then going to multiply the 1 on the outside by the 3. So 1 times 3 is 3, and I'm going to put that number right there. I'm then going to add these two. So 0 plus 3 is 3. And then I'm going to repeat the process. So I'm going to multiply the 1 times the 3. 1 times 3 is 3. And I'm going to add right here. 8 plus 3 is 11. We'll do the same thing again. We'll multiply the 1 times the 11. 1 times 11 is 11. And we'll add right here. Negative 7 plus 11 is going to be positive 4. One more time, we'll multiply. 1 times 4 is 4, and we'll add and get 8. Now, once we've done that, we're going to take the last term and identify that as the remainder. The other 4 terms, we're going to add the x's back into. So keep in mind that if you divide 3x to the fourth by x minus 1, your answer is going to have a reduction in the x power by 1. So my first x power, instead of being 3x to the fourth like we have here, it's going to be an x to the third. So we're going to have, and I'm adding these x's back in, I'm going to start here with this 3. This is going to be 3x to the third. And then I'm going to work my way down. So then I'll have plus 3x squared plus 11x. And then the last number will be the constant of 4. Now, typically, you will see that remainder written as a fraction, so we'll write 8 over what we divided by, so x minus 1. And so this will be our answer when we did synthetic division. And keep in mind, if you remember how long division works, this is quite a bit faster and easier than doing long division. All right, let's try it one more time. This time the directions are a little different. We're asked to show that g of x, including x plus 3, is a factor of 2x to the 5th plus 5x to the 4th minus 2x to the 3rd plus 2x squared minus 2x plus 3. So again, let's set up our synthetic division. Remember, on the outside, since we're dividing by x plus 3, I'm going to put a minus 3. Always the opposite of that number goes on the outside. And then we're going to put the coefficients of f underneath. We don't need any zeros here because every term is accounted for. So I'm going to start with 2, 5, negative 2, positive 2, negative 2, and 3. And then we're ready to begin our process. So I'm going to start by dropping the 2 down. And then we're going to multiply and add. So again, we're going to start by multiplying negative 3 times positive 2, putting the answer right here, and then we're adding. So 5 and negative 6 is going to give me negative 1. And then we continue with that process. So negative 3 times negative 1 is positive 3. When I add, I get 1. Negative 3 times positive 1 is negative 3. When I add, I get negative 1. Negative 3 times negative 1 is positive 3. And when I add, I get positive 1. And then finally, negative 3 times positive 1 is negative 3. And when I add, I get 0. So remember that your final term is the remainder. And if that remainder is equal to 0, then that proves that x plus 3 was a factor of f of x, because it essentially means that it divides in evenly and it doesn't leave a remainder. So I'm going to make myself a note of that. So if my remainder is equal to 0, we have a factor. Now, the problem did not ask me what the quotient was when I divided it out, but I'm going to go ahead and put the x's back in just so you can see what that answer would look like. Remember that we're starting with 2x to the 5th, so as I divide 1x into this process, my first answer will be to the 4th. So I'm going to say 2x to the 4th, and then I'm going to work my way down. Minus 1x to the 3rd, plus 1x squared, minus 1x, plus 1. And so the answer that we actually get when we do the division, we'll drop some of those 1s, would be 2x to the 4th, minus x to the 3rd, plus x squared, minus x, plus 1.